Well, I'm finally sick and tired of this reduced engine power notification on the DIC. We're going to see if we can fix that today, so stick around. What is going on, everybody? Welcome back to the garage, and let me get the spiel out of the way. As always, I want to thank all the new subscribers. If you have not subscribed, click the subscribe button down there, ring the bell. If you got any good comments, questions, things like that, that's what the comments section is for. And then, of course, always check out the links. We got links to the tuning playlist where there's just a plethora of tuning information in there. We've got links to the Patreon, to the website, to the merch, all that stuff. Check it out. And as always, I want to thank all the new subscribers. We're growing big, we're going fast, I love it. We're sharing information, we're diving into more stuff, including today's topic, which is on Project Country Club. Since we've added the Holley Terminator in there, we still have the factory ECM, and it's doing a couple things, particularly like with the start circuits and things like that, because this has the C6 Corvette on-off accessory button on there that the BCM has to send the signal over to the ECM and stuff like that. So there's a reason to have the ECM, the factory ECM, kind of in the background doing the old things that it was doing. But it is also sending us this reduced engine power message, and that's because it can't see the throttle body anymore. And so I went through and I scrubbed through all the lists of DTCs for this ECM and found all of them. There's about 10 of them that can send the reduced engine power message to the instrument cluster, and all 10 of them have to do with either the electronic throttle or the accelerator position, which is all mingled together. Now, we are bringing all that in through the Terminator X Max. We've got the drive-by-wire variation of it. Because of that, we don't have a signal coming back to the ECM. The ECM gets a little bit mad about that, but we're going to try and spoof the ECM today and see if we can't convince it that there's actually a throttle body and accelerator pedal hooked up to it. Now, there's a couple different things that we need to do. For one, we've got to be able to output the voltages that we would normally see on TPS 1 and 2 and accelerator position 1 and 2. So there's two sensors per each. On the TPS in this situation, one of them is high whenever it's closed and the other one is low. Then on the accelerator position, they're both low, but they're not the same voltage. They're offset a little bit, and that way it can see air between the two as you're pushing the pedal or opening the throttle body. But we can go into the tune, what we can do through HP Tuners on the ECM, and go in and basically go into the table that says whenever we're at this load point, yada, 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 this is the position that the throttle should be set in. So we can set that map square all the way across to say this throttle position is normal for all loads. That should help us out in that aspect of it, but we still have to get a throttle position back into it. We got a couple different options to do that, and in fact, I got them both here. You'll be very surprised to see how exactly small they are. One of them is a voltage buck converter, and basically this takes an input voltage, doesn't matter what it is. In this case, I think it's 5 to 20 volts DC, and then it outputs a voltage that you can adjust by a very, very, very small potentiometer on there. Now, the problem with this is it only goes down to 0.8 volts, and we need to get down. One of the sensors is at 0.44 volts. We can use resistors to actually split that in half, and I've gotten one of these down to read 0.44 volts, but we're going to try something else first, and that is some of these devices. Now, we're going to need one of these for every circuit, so we'll have to have 4 of them, just like with the buck converter. This is a MOSFET power supply, which takes a pulse width modulated signal in and then turns that into a desired voltage out. So we'll have to hook it up to something. We happen to have it. It's called the Canny 7 that outputs pulse width modulation, and then we can set those pulses and durations to eventually dial into the output voltages that we need to see based on, I took a screenshot of the Holley Terminator because you can see all the voltages on there. So the idea behind it is we will hook one of these up. In fact, we're going to have to hook 4 up, but we'll go ahead and hook one of these up and jump on the software and see if we cannot output the specific voltages that we're looking for, which is 0.44, 0.8 something, 0.9 something, and then like 4.4. So we've got to get those 4 voltages. That's at 6% throttle, and then we can just plug in the throttle table at 6%, and hopefully the ECM will accept it and say, okay, everything looks fine now as far as the parameters that I'm looking at for the throttle body and the accelerator pedal. Go ahead and quit saying that we have to go into limp mode. No guarantee that this is going to work. I don't know that this has really been done before, because a lot of people just say that you can't, you know, do away with the electronic throttle body on these ECMs. And this is probably not a solution for people who are asking, can I go from drive-by-wire to cable throttle on a Gen 4? Honestly, I think that the way that it would work, it would mess up some of your other load tables, but we're not using any of those. So as far as we're concerned, as long as the ECM doesn't get mad, because it is seeing revolutions, seeing RPMs, as long as it's not getting mad about the RPMs and the throttle body not moving in time with those RPMs, we should be all right. But that'll be the question we ask whenever we get done. So I'm going to do some wiring and soldering to get these things ready. And then whenever that time comes, we'll jump back in and I will bring you in, show you kind of the loose setup that I've got, because we're going to temporary mock all this stuff up, see if it works before we do a permanent installation. Stick around. Okay, here you can see kind of the finished assembly we got going on. Here's the output side of the harness from the Canny 7. We're on channel 0, 1, 2, and 3. Going into the pulse width modulated inputs, we have jumpered the grounds all the way through, including to here, because we're in a car, we can use a common ground all the way across. Same ordeal with the voltage in. I threw a fuse tap in there for now, just so we could get power to it, and then we'll just be checking individual voltages out and making adjustments in the software. So I'm going to go get this portion hooked up in the car, try and set this up where you can see the meter as we make changes, and I'll also show you the screen as I make adjustments to the pulse width modulation, and I'll talk through that a little bit, explain what's going on there. Okay, so I've got the file open up, and this is the one that I've made changes to for the throttle fix, but this also has the shutoff relay that I talked about in one of the earlier videos. You're not going to see my face. I'm just going to pop up a window showing you the multimeter hooked into the channel, and then we'll talk about what's going on here. Well, here is where we set up the channels. We got to set up IOs 0, 1, 2, and 3, and we have them set up as pulse width modulated. If we come in here and right click and do select from list, we can see our options. We can do output on, weak volt with a float, strong volt with a float. We want to do strong voltage with a weak ground. That gives us the best results. And then down here in the right hand corner, we have all of our parameters that we have set up. We're not using anything fancy in here. We're just setting up our period, which this is, we're going to start with 500, which is half a second. The period is the window in which the pulses will go out. And so if we were to put this to 250 output in a 500 period, that means half a second, it would spend a quarter of a second high. So we'll load this up at 250, see what kind of voltage we get out of it, and then we'll start making adjustments from there. Let me go ahead and turn the car on here. Okay, so we'll connect up, and we're going to write the diagram in here. Now we will turn the device on. And interesting. So our pulse width is too wide, and that's why it's kicking on. So we need to go to a shorter period, and I'll show you what I'm talking about. So let's drop this down to 100. You can see all the devices were lighting up. That's because we're writing outputs to all the devices. And let's take this down to 10 and see if we can get a steady output. As I said, this may not work. There's no guarantees. Okay, let's try and run it again. Period's still too wide from apparently. We can try shrinking it down even more. We're getting pretty low already, which means that this device is probably not going to work. This MOSFET is not going to work well for us. If we were to flip it over to average, in fact, I'll do that right now. Right now at our setup, we are putting out 1.496, but the problem being, I don't think the ECM will accept this as an average. I think that it'll have high enough resolution that it would see the numbers bouncing around like that and it would get mad. So I've used MOSFETs in the past with PWM and not had this issue. It may just be that these are not worth it or not working properly. I do have some PWM to voltage conversions that should have a more steady output coming, but they're not going to show up until sometime in February. So if this doesn't end up working, we can revert back to the other style of using the buck booster, and we can go into that. Let's try lowering it one more time, see if we can get steady power. So if we bring the period down to 10 with 1, I don't know that this will make much of a difference, but we'll try it. Okay, let's see if this helps. Yeah, this isn't working either. I tell you what, let's change the PWM style and see if that makes a difference. Let's go to strong volt. Actually, let's go weak volt with a float on the first channel. Let's bring this back out to 500 and 100. Still bouncing a lot. Okay. Got one more option that we can try, and that's strong volt float. I don't think that this will work either, but we're going to exhaust all options before we give up on the MOSFETs. Nope. Okay, well, that answers our question. The MOSFETs, at least these MOSFETs, are not going to work. In the meantime, we can use the buck converters, and then hopefully, honestly, that's probably a better option anyways, because they're a linear style, and so they're not going to change if the input voltage changes. I've tested them from 6 volts all the way up to 14 volts, and the output stays consistent. And then we can also probably package those things up and mount them right by the ECM instead of having to run a harness all the way over there. But let's go ahead. I'm going to put the original file back in here. And let's do a wrap up. Well, I'm a little bit bummed it didn't work out, but I'll be honest with you, these MOSFETs were about the cheapest ones I could find, which is probably part of the problem. And for the most part, what I could tell is they were basically just passing on the PWM. Now, for no more of the load that we were going to have on the ECM, if that were to work, we could take the direct PWM out of the Canny and use that, because it produced basically the same thing that we were seeing here. If you were to average it out, you could see what the average voltage would be within a period of time. But that's not going to work. So these are great. These are good for up to 15 amps. So if you have a high load device that you're trying to power with pulse width modulation, these would work better, a motor, things like that. They're just not going to work in this situation. Now, there are some MOSFETs out there that I've used in the past that will take in the input pulse width modulation and output a smooth, flat DC curve. I was hoping that would be the case. Unfortunately, it was not. That does not mean that we're done trying to tackle this. As I said, we have the buck converters that we can try out. I know they work. Only one of them needs resistors on it. So that's going to happen in the next series of trying to fix the reduced engine power error that we are getting because of the throttle bodies. And then, as I said, we do have some PWM to voltage converters, which my guess is I would think that they would just basically be MOSFETs, but maybe they're not. We'll check them out whenever they show up sometime next month on the Slow Boat from China. Once again, not the most money spent on those, about $2 each. Thank you, AliExpress. But you never know until you try, and this is a fun little experiment that we could try out. And this would actually work good for driving a PWM fan if you needed to. If you didn't have something that was already set up to drive a pulse width modulated fan, or you needed if you wanted to take a fan that was not pulse width modulated controlled, that didn't have too high of an amperage. Fans on a car like this probably pull 30 to 40 amps, so this necessarily wouldn't work, but you could get a bigger MOSFET and actually create a variable speed fan, things like that, by using the same technology, where you've got a small device like the Candy 7 or a Raspberry Pi that outputs in PWM, and then you run it through a device that can handle more current across it. So that all being said, we're going to wrap this video up for now. We're going to come back and attack this and figure it out. We've got some more stuff to get done this week. As usual, we've got a lot of stuff to get done. In particular, we're going to dive in very quick. Let me grab this. We have a nice Chinese-made PC USB oscilloscope that we are going to use to go in, look at signals from things like the cam sensors, so we can figure out if we can get sequential fueling to work on this setup. Even though we have untimed, it would be nice to get standard sequential fueling setup. This thing was about 50 bucks, a lot of good reviews out there, so I'm going to be doing a video on this very, very soon. Ought to be interesting. I haven't messed with an oscilloscope in a few years. Used to use them a lot in the Air Force, so I'm anxious to dive back in. And man, there's no better time whenever you can get something like this that has a 20 megahertz resolution, 2 channels for like 60 bucks. Great. So that being said, make sure, as I say, if you haven't already subscribed, do that now. If you got any suggestions on better ways of getting that 4 different voltages out besides using a buck converter, remember, one of them's got to be 0.44 volts. Really hard to find a buck converter that's not super expensive that will go that low. Go ahead and hit up the comments. If you got any questions on what we were doing today, hit up the comments. As always, thank you for stopping by the garage. And remember, ABT, always be tuning.